Now, if you might remember our enemy character here, we created a jiggle joint on him. Put this little joint in his belly, right there, so we can give it a little bit of a wobble wobble there. So there's nothing here in our blueprint that we've created that will manipulate that joint. And we could bake it in the animation, but that's not nearly as much fun. Besides, we would have to create a whole set of animations for him separate than the other character just to get that to work. Or we would have to make sure that our animations included all possible joints. It becomes kind of a logistic problem at that point. What would be nice is if we could customize the Anim blueprint just for this character. Fortunately, there are two ways to do that. If we create a new animation blueprint, we'll call this Jiggle Anim BP. So right now it's completely empty. But what we can do is we can tell this blueprint to reference our original blueprint. Sub Anim instance. So here in instance class, we'll pick our original animation blueprint. Now again, this gets a little bit more confusing because we go back here, we can override the variables, but we can't override the animations. So if we wanted to use that technique where we created a child animation blueprint class to give him a different animation set, then the anim instance would have to reference the child one. We can't override it here from the instance. So in that sense, it is a little limiting. But now that we have this, we can plug this in here like this. And again, we don't have access to the previewer like we did before, which is another kind of limitation. But this would work exactly as it did the last time. So now this gives us the ability to go through and branch off of this and add what's called a spring controller to that jiggle joint. There's a whole library of skeletal controls that allow you to do things like manipulate the joints directly on the character. So if we branch off with this and I try to do a spring, nothing happens because we have to convert from local to component space first. Now we can add our spring. And actually, if you back up a minute and I would just go skeletal controls, you see there's a whole list of cool fun things we can play with. But we'll go ahead and put it on the spring controller. Now to go back to the pose, we have to convert again. Now if I go directly, it should add that conversion for me automatically. And again, like pretty much all the nodes, there's an alpha which will turn this effect on and off. If we go into the spring controller, we have to select the joint. Now notice this is not a pin. This is another reason why being able to customize your animation blueprints like this is extremely helpful, because we can't plug this in as a variable. It's just not exposed that way, which is in itself very limiting. But because we can create custom anim blueprints per character, we can work around that problem. So now we have the spring controller on. Let's go ahead and limit its displacement. What that's going to do is it's just going to limit how much it can move, and let's give it 25. Here we can filter out what axis it's allowed to move or rotate in. By default, all translations are on and rotations are off. And so now if we can compile this, and again, it's a little hard to preview it, but what we can do to test it is let's just go ahead and override the sub-anim instance with our run animation. And you can see that joint just kind of jiggling away right there. And again, if that's too much, we can come in here and we can tone that down. Let's crank up the stiffness to 75. Max displacement down to 20. Recompile. And we can keep playing with it until we get the motion that we are happy with. We can also see if we can. So now we've limited Z motion, so it's not bouncing up and down. I don't want to keep the up and down. Let's try the Y. There we go. So now it's not going in and out as much. It's just going up and down, left and right. And you get the idea. And so now that we've tested that, we can go ahead and plug that back in. And now our enemy guy is ready. And again, his weighting's all screwed up because we killed all those joints and didn't bother to fix his weighting. This is fine. This is just garbage weights. We just never bothered to clean them up. It's not a bug in Unreal or anything like that. So if we save that, and then what we can do is on our enemy actor, we can set that to the jiggle animation blueprint. And as you can see, that's already popped them in the idle, just waiting for input. Now there's a second way we can do pretty much the same effect. Let's go ahead and set him back to the test anim BP. So now it's the exact same animation blueprint, but without that jiggle deformer or that jiggle joint bouncing around. So what we can do at that point is just go back to the mesh. And here under mesh, there's a relatively new feature called post-process anim blueprint. And here we can apply that jiggle anim blueprint in there. But it's not going to work quite like that. So we've assigned the jiggle anim blueprint, but the way it's set up right now, it's not set up to work correctly with the post-process animation. This sub-anim instance is for how I demonstrated it the first time. To use it as a post-process, so instead of the sub-anim instance, what we want coming out of this thing is the subgraph input. So right now it looks like he's doing nothing because it doesn't know what the subgraph input is. It doesn't know what the base class is. That's set up in the pawn. So the animation blueprint has no clue what it is right now. But this is basically two ways to get the same effect. So now, if this guy is hooked up to test anim blueprint, and then his mesh is using the jiggle anim BP set up to be working as a post process, we will get the same effect. And this is really cool because then basically every character can have its own little anim blueprint to handle whatever joints are jiggling or have to be procedurally animated or whatever you're doing. And you don't have to wire that in the main one for every single case. You can totally customize each individual character this way. And doing it this way also helps keep your pawn way cleaner, because instead of having 15, 16 different pawns, each pointing to a different mesh, and that mesh having to point to a variation of the anim blueprint, this allows you to just basically plug in your character, plug in your Anim blueprint. If you're using the Anim structs, you can use the same Anim blueprint, just override the animations in the Anim struct. And then all the customization happens here on the mesh level as a post-process Anim blueprint. The downside of this currently is that Anim montages will break this. When you play an Anim montage, this post-process Anim blueprint just is not being evaluated. Now again, that is at the time of this writing. By the time you get a hold of it, they may have fixed that. Take it with a grain of salt. So currently what we're doing is we're doing it this way, where we're creating a Anim blueprint per character. The Anim blueprint references that base Anim blueprint, and then our actor in the pawn references the top level Anim blueprint. So that way, if we wanted to do an Anim montage, the Anim montage would actually go in here. Because it doesn't, Anim montages also won't trigger the sub-Anim instance either. Once you hit a montage, this thing here is just not evaluated. But if this evaluates first and then the montage happens, then everything's fine. So that is our current workaround.